Hey, what's happening, guys? Today we are taking a look at this. This is the Gochifix Oscilloscope Multimeter Waveform Generator 3-in-1. So we got here DC voltage, AC, DC current, resistance, capacitance, frequency, duty cycle, diode test, on-off test. I think that means probably continuity, fuse, bandwidth, output. Anyway, this is from Banggood. They sent this out to us free of charge for our consideration. This may not be the correct manual for this. It is not. There we go. That's the correct manual. So we got a nice little manual here. And some sort of addendum. Oh, okay. Operations diagram. So to get into the oscilloscope, we need to press the auto button for 2 seconds. To get into the signal generator, you have to press the light waveform button. Okay, well, that kind of makes sense. So multimeter operation. Press and hold F4 to turn off the beeping. Okay. All right. Let's see what we got. USB-C, very nice. But what am I not seeing? Have you figured it out? What I'm looking for? There's no BNC connectors on this. Oh, nice screen. All right, let's start off with some voltage testing. And for that, I've got the old AD584M, which I've made up some special connectors. These are really thick wire connectors, so there shouldn't be any loss, hardly at all. It's got a nice stiff stand. That'll hold up to some abuse. All right, so we're at 2.5 volts. Seeing 2.505. Switch up to 5 volts. Seven and a half. Huh, a little slow on that. Right there. 10 volts instantly. 2.5. 5. 7.5. 10. Okay. What I was doing there is I was going through here looking at this. This is telling you, I guess, the range before it's going to switch up to another digit. Let's see how many digits are in this thing. Hang on here. Okay, so right here we have a 6,000 code digital multimeter. So what I believe this means is anytime we're going up over the digit 6 at any of the points, it's going to switch a digit. So let's try something here. I'm going to disconnect the AD584, and I'm just going to connect up here to a power supply. All right, so there's 5 volts. And now, if I take this up to 7, see how it went? See, now we're under 5 volts, and it's showing our maximum there of 6. If I take this up, now we're at 13, our maximum is 60. Now we're at 31 volts, maximum of 60, and it's showing us the little, telling us, you know, that could possibly be a dangerous DC voltage. So, yeah, really nice for the voltage. Let's do some AC voltage testing here. All right, let's disconnect you and you, and these leads, we'll get them out of here. And then we'll do what we do with every single multimeter we test. We put on the probe master leads. The reason I do that is so that we are not testing the leads that come with the multimeters, which are hit and miss. Every multimeter I have ever tested on this channel since 2016, 2017 has been tested with this set of leads. All right, so voltage. See, it's in auto is 600 max. Take these little clips off here. Yeah, it's stuck on DC. How do we switch to AC? I'll have to figure out what that is. Select. There we go, AC. 124.7 volts. I don't know. I think it might be making a sound. I can't tell. Yeah, that's good. Very good so far. All right, I thought we might take a little talk about what all these buttons are and what they do. Start over here. Range button is the automatic range mode, which you can turn on or off. The select switches us between the different modes here. You see we're now in AC, or DC rather. Now we're in AC. Now we are in frequency mode. This must be PWM mode, duty cycle. Then we're back to DC. pH we'll get to in a minute, and then we have the relative here, which is kind of nice. What you can do with this is basically give it a reference voltage. So what we need to do is give it a reference voltage. I'm going to put my power supply on 6 volts. Let's get it hooked up here. All right, so there's 6 volts. Now, if I press the relative button, that is now our reference. So if I change the voltage, I'm now only giving it 4 volts. It's telling us we have a negative 2 volt difference from our reference, which is very nice. So now the pH, this is peak hold. So if I press this, it's now telling us our minimum and our maximum values. And again, if I change those values, look at that. I went over the 6 volts. Let's take it down. So now we're at 3 volts. Our max went over the 6 volt limit here, and our minimum is 3 volts. So let's turn that off. Reset it. Exit. peak hold. Okay, so let's put it in a higher voltage mode here. Okay, so there's 20 volts. We're in auto, right? Are we in auto? I'm not sure. Let's go back and just reset it. All right, now we're in auto. We're at, it's supposed to be at 20 volts. Hang on here. I'm going to knock this up to 20. Come on. There we go. Okay, so now I'll take our relative measurement of 20 volts. And we're locked in at 60. So as long as I don't go above 60 volts. Oh, shoot, wrong button. All right. Hang on. All right, we're set for 20 volts in auto range, peak hold, 20 and 20, okay? So now if I hit the V set over here, now I'm showing 30 volts over there. You can see we have a 30 volt there. And then we'll go the other direction, down to 6 volts. And now you have our instantaneous reading, our maximum reading, and our minimum reading. That's pretty nice. That's a really nice feature. All right, I'm not going to go through a whole bunch of all the different things. You can see it does millivolts, diode, continuity, capacitance, frequency. Yeah, we'll do a frequency check. What the heck? I got something set up here. This should be a 10 kilohertz sine wave at 5 volts peak to peak. I'd say that's spot on. Considering I'm not using any sort of termination or anything here, I mean, that's not a problem at all. We also have microamps, milliamps, megaamps, and another off switch over here. So let's put this guy into oscilloscope mode, which you do by holding the auto button. And now it's an oscilloscope. So let's fire up the function generator here. And we'll put it through some tests. However, we're using multimeter probes to do this. I got to take points off for that. I mean, it's going to be fine if this is your first multimeter and you're just learning and you're playing around on your bench at home. You're not going to notice a difference. But for professional use, I don't know. Seems like you're really missing something here. The probes aren't adjustable. They're not coaxial, so you're going to pick up noise. Basically, what do you have when you have two parallel conductors separated by an insulator? Well, you have a capacitor. So there's going to be capacitance. And oscilloscope probes are built to filter that kind of thing out. Okay. I'm giving it a 10 kilohertz peak to peak sine wave. Why am I not seeing anything? Confusing. All right, there she is. All I had to do is hit auto. I don't know why I wasn't seeing anything at all there, but so it's looking pretty good. We're seeing 5.2 volts peak to peak, 66.4 millivolt average, 1.82 volts RMS, and a 10 kilohertz count. That's very nice. We're looking at 2 volts per division, 50 microseconds per division. We are in auto trigger on a rising edge. All right, let's goose this frequency up. There's 110. Yeah, right on it. 610. Yeah, right there. There's a little over a megahertz. There's 10 megahertz. Now look, you're starting to see a little bit of the signal riding on top of it there. All right, at 10 megahertz, it's starting to get just a little bit flaky. 20 megahertz, whoa. Yeah, see, it's definitely lost its count there. Pretty solid at 5. All right, let's try some different shapes. There's a square wave. That is a 5 megahertz square wave, friends. All right, let me take it down. There's 1 megahertz. Man. This is probably not a problem with the oscilloscope, but more a problem with the connections and the wires. Yeah, it's just not great. All right, here's 10 kilohertz square wave. Which still is not beautiful. 50 kilohertz. Again, all this noise and spikes you're seeing are because of the way this thing is wired. If they'd put a BNC connector on here, you wouldn't have this problem. All right. Triangle wave. Yeah. Like I said, it's not the greatest oscilloscope in the world, but you know, if you're starting out, this will definitely get you going. All right, let's take a look at the signal generator function next. Okay, so now we are in the frequency mode. You can see we have a square wave at 1 kilohertz, 50% duty cycle, 3 volts peak to peak, and if you look over here, we have 3.2 volts peak to peak, 1 kilohertz. So let's see if we can't change this a little bit, yeah? All right, I just moved everything over here so you can see a little bit better. So we can change the waveform by pressing this key here. Oh, There we go. So now we have a sine wave, ramp wave. Oh, so you have 3 choices. There's nothing wrong with that. Let me change our frequency here. Let's see. Oh, wrong button. No, that's the right button. 10. Come on. Hit exit. There we go. There you go. 3 volts peak to peak, 10 kilohertz. Let's go back to waveform, square wave, exit, and let's change our duty cycle to like 75% somewhere. 70 is fine. Yeah. Not a bad little signal generator. Not at all. Cool.